And with that, I will turn over to our speaker, Dr. Amber McKenzie. Amber and I worked together in a prior life. She's based out of Knoxville. I'll let her give the rest of the bio, but we appreciate her joining virtually to educate us about NLP.
Thanks. Thanks for having me. And I'll leave it a bit informal. If you guys want to ask questions, I'm fine with that. I mean, there's like a handful of us, so no big deal there. So I was going to talk tonight about efficient NLP and ML. And this is me. I've got a blended family. There's a bunch of us. So in the COVID world, that makes for a lot of people and a bit of craziness. I come from the University of South Carolina. I did a little bit of work at Oak Ridge National Lab, doing some stuff I can't tell you about, or I'd have to kill you. Worked at a startup data science consulting company, worked at Dialogue Tech under Tim, survived, and ended up at PwC. So here we go. So where are we going with this? Well, in the beginning, there was nothing. No, just kidding. We're not going to go that far back. But as is the case with humans, we sort of start out with something that is a little more rudimentary, and we make it better. And then we can't help ourselves, but we make it better and faster and bigger and more. And we just have to go until, it's more and more and more. And the same thing is true for AI and ML. I was just having a conversation the other night with a neighbor, and he was telling me about how he'd had another conversation with somebody who was like, yeah, in 40 years, somebody was telling me we're going to have an AI that does everything for us, that, we can do everything that we can do. And I was like, well, that's not exactly true. Things are actually pretty hard, but it goes to tell you that, the perceptions are there, because we start from something like this, like a toy, and we go to robots that, have iPads in front of them. And then we're going more and more into, the spaces where we've got robots that can do things like Boston Dynamics, or jumping, over cars and sniffing out bombs and, do all sorts of cool stuff, right? The same thing is true for algorithms, right? We're in the data science space. So we've got the basics, right? So, now these things, years ago were pretty cutting edge. They were pretty cool. They were hard to deal with. And now these are where you start out, right? And then now we're headed into the deep learning space. We've got, all these hidden layers. Now we've got deep learning. You can throw all the things into it. And now we have to have, specialized hardware to run them. And now we're even headed into things that are mimicking our brain, right? So algorithms that we don't even quite understand how they're working, why they're working, those type of things. And then even hardware, right? So we've got chips, we make them smaller, we pack more things in them, but they're using more energy, and we still need them bigger. So we've got CPUs and we've got GPUs, and still that's not enough. So we have to build computers that fit into warehouses, right? Just to run simulations. And then those aren't big enough, so we have to have a race to see who's got the top the supercomputer in the world. And now we have it. No, now they have it. No, now we have it. And Titan's knocked off again and has to get, retired because it's not good enough anymore. Sad day for Titan. And NLP, which is my specialization, is no different, right? So in language, you can start off at just the word level, right? So you can just take simple words. That's how we learned our language. You just put letters together, create these words. They've got some meaning, and that meaning suddenly explodes into books, right? And now suddenly we've got all of these concepts that go together that turn into massive concepts, stories, and then into language that we're now talking. So the things that I'm saying to you make sense, hopefully, right? Things that you're hearing, waves and stuff turn into words that your brain translates into meaning. And then we use computers to translate that. But first, it was encyclopedias, which I'm pretty sure that my kids wouldn't know what those were, right? We had all these books that had all of our knowledge in it. And then we decided to take all of that knowledge and throw it onto the web for people to see, right? And then we were like, well, that's pretty inconvenient. I would like that on my watch. Because why not? That's where it needs to be, where I can have it all the time. But what all of that requires is natural language processing, right? We have to have some way for the computer to analyze that language in a way that it can understand enough to provide us with the information that we need, right? And that requires algorithms, that requires processing, and it requires constant revision and constant research over time. And what's happened is we've gone from things like rules-based systems, right, where we took language and we tried to fit it into these specific rules. So we said, okay, can we create a specific grammar that will be able to create any sentence that could possibly be in language? And we're like, that turns out to be really hard. And it likewise turns out to be really hard to create a rules-based system that can handle language like that. And then we were like, oh, well, now we're getting data in the 90s and the 2000s. So we're just going to take all this data and throw it in there, and we're just going to let the computer figure it out. We're like, well, it's not doing real great, so let's refine some of the algorithms and you know, let it learn from it. And then we headed into the deep learning. But you can see over time, we've headed less into linguistics understanding and a lot more into just machine learning. So we've gone from needing to know about our language to just letting the computer do it. But the computer needs a lot more computation, and that this chart does not take into account. And what that has led us to most recently, which has become a common household name in NLP, is BERT. And I'm not sure how many of you guys are familiar with that. It's not super important there, but what you need to know is the current trend in NLP is language modeling, a way of kind of representing language for the computer so that it can use it in different ways. And it does this in order to kind of get at the meaning as opposed to just representing it in ways that it can just manipulate it. And BERT is the current, I don't know, soup of the day, if you will, in terms of language modelers, although they're continually making new ones. But what's interesting about BERT and the other language modeling algorithms that have come out recently is that they're very computationally intensive. So if you look at this chart, on the left-hand side, what we have are the features that are used in one of these models to train it, okay? And that B stands for billions, okay? So if you look here, back in 2018, we started with, I think, the BERT one down there. And the BERT large uses, you know, around, now that I can't see, it's on a small screen, 300 million features, all right? And they're like, well, that's not quite enough. We're gonna up the ante. GPT-2, which was the next sort of iteration that everybody jumped on the bandwagon, had 1.5 billion features. And then, of course, not to be outdone, Microsoft came out and said, nah, hold my beer, 17 billion features, okay? That's ridiculous, right? In terms of the volume of data that we're using to train these models, it's huge. But when you think about language, language is huge as well, so it's not surprising, okay? So when we go from bigger and better, it naturally translates to more and more. And what we're going from is something that probably everybody has thought about before, right? Obviously, you know, it's pretty intuitive to think that we as humans always go bigger and bigger, or bigger and better, right? Not necessarily bigger and bigger, but you know, we want the latest and greatest. We want to go better and better. But we don't always think about sort of what it takes to get there. And the first thing we need to think about is, the first thing is time, right? So if you're data scientists out there, probably you've always been in this situation, right? When you're waiting for a model to train, you sit there, you're like, you got it all loaded up, and then you hit the button and you're like, all right, how long am I gonna sit here? Well, the BERT large, with its 345 million parameters versus the 110 parameters for its smaller version, takes 16 cloud TPUs to train, which are their tensor processing units from Google, and 4 days to train that model. And then to predict, it takes 1 TPU to predict. And then the base model takes 4 days on 4 cloud TPUs and 1 GPU to predict. That's a pretty hefty model, right? In addition to the time, we've got more and more energy, right? So when you start thinking about the energy costs, okay, it might not have occurred to you when you start using GPUs to train your models and that sort of stuff, the energy cost that goes into that. First thing we want to think about is something like a supercomputer. So current supercomputers, and I did put this together earlier in the year, things might have changed around then, things move fast around here. They need the energy equal to a medium-sized city like Spartanburg to run. We're constantly moving towards something like exascale, right? Exascale needs the total output of an average sized US coal plant. Something you've probably heard about, Bitcoin, you know, it was all the rage recently. I don't know if it's died down sufficiently enough to say that it was like the .com yet, but you know. But the current energy expenditure for Bitcoin alone rivals the total energy consumption of some nations. For example, Switzerland and the Czech Republic. And then if you look at something like a Bitcoin transaction, which there are more than 390,000 transactions that occur in a single 24-hour period, it takes 470 kilowatt hours to complete a single Bitcoin transaction. And that's the equivalent of powering the average American home for 2 weeks. That's significant, right? That's nothing to kind of, you know, look down your nose at. And if we've got more and more energy, that translates to more and more resources, right? So when you start looking at some of the data that goes into things like cloud computing and what, you know, whether different companies and countries are using renewable energy and whatnot, here's a little bit of a breakdown that I found, which I thought was kind of interesting. You know, you have to start thinking about what you're using, you know, what your carbon footprint looks like, that sort of thing. So a single Bitcoin transaction using blockchain technology results in roughly about 200,000 grams of carbon dioxide per kilowatt hour consumed. And so that's the equivalent of burning through 2 14-gallon tanks of gas in an average American car, right? And the Bitcoin system has a carbon footprint of between 22 and 22.9 megatons per year, which is comparable to cities such as Hamburg, Vienna, or Las Vegas. That's crazy, right? And then you look at, like, you know, I got a little embarrassed, honestly, when I looked at this. You know, Germany, spot on, right? Renewable energy, right up there, 40%. United States, really think that we could be doing a bit better at 17. But obviously there's a lot that goes into those figures. And it was a bit eye-opening. Amazon AWS is a little bit behind on the curve. Google's a little more up there, Microsoft, that type of thing. But I personally had never thought about the mix that they have, and that they have choices as to what they pick, right? And then, so when you get to the point where you start people thinking on how much energy they're using, you've got to start with computationally intensive things, okay? So things like simulations. Simulations obviously use a lot of power. Blockchain, we already went through, and Bitcoin use a lot of power. And so you say, okay, these things, we want to raise awareness, they use a lot of power, and we aren't talking about the climate implications of using these things, and you know what that means. And we certainly aren't talking about climate change and ML or NLP. I doubt any of you have thought about that before, because I certainly hadn't. Where I went for that was, oh, that's not where my slide is going. See, this is why I did this poorly, but that's okay. So what happens is you go from something like this to something like this. And my eyes were opened from, I ended up listening, so I listened to a podcast, it's called TWIML Talk, Today in the World of Machine Learning, I think. And she was finishing up her PhD, but she's now, I think, a research associate at Facebook or some such, maybe Google Brain, one of those cool places. But she gave a podcast on her research on the environmental impact of NLP. And I had never thought about it. I've been in NLP for a decade, and that had never occurred to me that that could actually be a thing. That, you know, what I was doing in machine learning and NLP might actually negatively impact the environment. And what she put in her paper was, you know, one of the things was this graph. And the two noticeable things here are this first number here was that the average car uses about 126,000 pounds of CO2, and that something like a BERT, the big one, to train it, uses about 5 times that, which is a kind of astounding number, right? And it kind of puts in perspective that graph that I showed earlier. So this graph here, we've got BERT here, right? And suddenly we've got 5 cars, right? Just the exhaust of 5 cars. And then it made me think about this one way up here, right? And now, that was in January. We've come out with at least 2, if not 3, more new latest and greatest models since the Microsoft one. And every time they come out with a new model, you have to think that in order to get to that point, they have had to train and train and train these models to research, right? To see if they're doing better, to make incremental progress, to see, am I any better than this other model that so-and-so put out before me? And how many of the different models that they tried did they throw away? And I'm certainly not saying that they shouldn't, or that they shouldn't have. We've got to do that research to progress. But I think they should think about it, right? They should make decisions based on good underlying, you know, knowledge, right? And that's what I'm getting to, I guess, is that, you know, if we don't think about things, we're going to go from, you know, something like this to that in a matter of minutes. And that's where I'm trying to get to. So what can we do? And I originally put this presentation together for my company, actually. I did an internal presentation and I was gonna change it, and I decided not to because I felt like it actually is still applicable more broadly. Because what has to happen is change regardless, whether it's within an organization, whether it's without, it's all about research, policy, education, culture, and impact. Now, whether you have impact in those areas, you know, depends on where you are and, you know, whether you have influence there, but it still needs saying, right? So in terms of research, what needs to happen is this stuff needs to be researched, and the internal practices of the people who are impacting these areas needs to be examined. So in the universities, they need to sit down and think about whether all the research that they are doing to develop all these language models is truly necessary. Do we need to be training these models day in and day out to make incremental progress? Or can we do more collaboration across institutions to where we're sharing more knowledge and we're not just, you know, doing so much competition that it's driving up more negative climate impact, right? And then within firms, some of these environmental concerns should drive choices that we're making in terms of algorithm choice, things like that, right? And then policy change. So we should be discussing these things within the firm, you know, or organizations or groups, right? So obviously, if you guys were still getting together as a broader group, it would be really great to have a broader discussion about what are you doing within machine learning that may have an impact in this area? Because that's where change starts, right? Is by having discussions and figuring out whether things that you're doing have an impact. And then enacting change. So this part was a little bit more firm focused, but determining parts of culture and firm changes that would help, and testing potential policy changes for impact and recommendations about balancing solutions and efficacy. So you know, we actually within PwC are using BERT a lot. And it's because it's the standard out right now. Is that necessary? Do we need to be using BERT all the time? Or could we, you know, could it be a policy that we start with some lower level algorithms and work our way up and only use BERT when we determine that it's a necessity, right? That would probably be a good policy to enact, but that's got to, you know, that's got to come from, you know, discussion and research. And change. Change is sort of the biggest, are we on, oh, change. Education. I'm all over the place, aren't I? Education. So this one for me is probably the biggest area that's outside of, you know, firm and organizations, because you can't make change without people knowing about the problem. That's what it was for me. I had no idea this was even a thing, right? That the NLP that I was doing could potentially do harm. That wasn't even on my radar, right? And so by sharing my knowledge with you guys, by sharing my knowledge within my company, hopefully if the virus, if the world ever calms down, you know, maybe I'll be able to give it at a couple of conferences, spread the word, right? Maybe it'll go further and we can start, you know, moving that along. And then education, you know, eventually moves to culture, right? Because what you want is that people start to engage, right? And start to say, hey, you know, rather than, you know, it just be something in the back of their mind, people start saying, hey, maybe don't use BERT first, right? Maybe use something else. And they need to use the knowledge that they have, right, to make those informed decisions. And this is actually very much akin to something like responsible AI, right? Which is pretty big right now, which is great, right? That area where we're like, hey, do you guys know that a whole bunch of these algorithms are super biased and you should be very careful about making making models that are biased and that sort of thing? That's awesome that it's out and people are talking about it. You know what? This needs to be out there too, because, you know, just like responsible AI, I don't know, I need a tag phrase for this, you know, environmental impact of NLP is a little bit long. So I'm gonna have to figure out like a hashtag or something like that. But you've got to figure, you know, you've got to get it out there so that people are kind of moving it along. And then you can make an impact. And by impact, changes propagate. We can be all in together in our mindless following of, you know, environmental conservation. No, really, it'll be great, I promise. And we can be the change. And one of the things I think that I would love to see happen is that rather than just start with the tried and true, research industry specific things that use less energy. So there was a paper out recently where it was called Improved Brain-Inspired Emotional Learning Algorithm for Fast Classification. So they were putting forward a classification algorithm that mimicked a mammalian brain, and it had sort of the characteristics of fast learning and low computational complexity. That's freaking awesome, right? So, you know, there are things out there where people are moving the bar forward in terms of trying to be able to replace some of the things we have with both better performance and better computational efficiency. We just need to get on board and move the needle, right? So why? We need awareness because that will, you know, propagate just like this little, you know, droplet throughout, you know, our industries and you know, our circles. And then, you know, whatever we're saving, number one, it helps with the environment. But number two, in any of the areas, you know, in your companies or any of the things that you're doing, your energy savings can go right back into what you're doing, right? So it's actually good money sense. And we just flat have a responsibility, I think, to ourselves and to our environment. That's sort of like the token tagline, right? Where we have to be responsible to our planet. Hug a tree. And change starts with thoughts and decisions. And our thoughts and decisions lead to raising awareness, saving money, and preserving our planet. So I've got all sorts of references, so you know that I'm not making any of this stuff up, but I'm going to go so fast that you can't look them up, so you don't know that I'm not making all this stuff up. But there's my contact info. You can look at my log, but if you're looking to make sure that I'm still alive, you'd probably already called a paramedic because it's not going to show you that I'm still alive. But yeah, thanks for listening to me anyway. That's all I have.
So since I may have to drop early, I will jump into some questions because I have a few. So are there, sorry, my dog's jumping on me from behind. So any effort to, or have you seen any papers that are doing comparisons? And what I mean by that, so the example, Bitcoin, as far as I know, they know a lot about that, because my understanding, like current Bitcoin, you don't generally just do that on a stock machine. People, it's because they're so inefficient that people buy these special devices that are trimmed down to use very low power and do just those specific things. So I think they probably have the numbers pretty accurate, but if you said, okay, per 1,000 people that use that system, how does that compare to per 1,000 people that use a credit card system? I don't think we have any idea what the power consumption is of credit card transactions, right? And similarly, other fields, NLP, right? I don't even know what the alternative is, right? You'd have to, that's very difficult because it's used for so many different things. To provide a comparison is hard. Not to say that the goal shouldn't be just lower it regardless, but if you had a comparable number, then you could actually say like, oh, is Bitcoin just fundamentally not tenable from an energy efficiency standpoint versus credit card, or would you be surprised to find, oh, it's a lot, however, it's better than credit card, so at least we would pick this in an optimization world. You pick this over that.
Yeah. So I forget her name. The lady who did it, Emma Struble. So when she did it, she self-admitted, she was like, this is sort of just like dipping a toe in the bucket. And she's like, they did sort of the best they could in terms of trying to estimate using, what they knew of GPU. So you can see in their thing, they did it based on GPUs and that type of thing. But hers was more about, I think, awareness than anything else. And she even encouraged, more looking into this and that sort of thing, because there honestly has not been much out there, certainly not on NLP. Hers is the first. There's been a little bit on machine learning, but not a lot. But hers is more like, hey, we need to be looking at this. People need to be, figuring out, what can we do about this, being more efficient, making better choices, that type of thing. So I don't know. I haven't looked since January to see if there's anything recent. So obviously it's been 6 months. There might be something out there, and I probably should. But there wasn't as of then. But yeah, I think it's definitely an area that it needs more research, and there just needs to be more talking. Honestly, I've thought about, like, it would be a good business venture if you could get traction to consult with companies. There are other consulting companies that do, like carbon emissions and stuff, but some of the, if people were starting to really look at computational and costs and that sort of thing, to be like, hey, we'll look at your computational costs, expenditures, and carbon emissions for that and that sort of thing, and try and help you lower them and help you brand it and sell yourself as much more computationally efficient, that sort of thing. If I thought I could get it off the ground, I totally would.
Yeah, I guess I'll be curious to see a couple of just technical trends, long term, how they impact this. And that's, the announcement this week of Apple moving to ARM, I think we've already seen other platforms do that a lot. I wonder if that trend will continue, or maybe even move into the server space with this a bit. I've not seen, I read a TPU paper at one point, but was not focused on this issue with it. I'd be curious to see the differences. A lot of people are still using GPUs, at least in the personal space, and that are learning machine learning. Anything special built is usually more efficient. So I'd be interested to see that comparison.
Yeah, well, I don't know, because last I saw, are TPUs out for, like, has Google put them out yet?
So you could like rent machines with TPUs through Google, but no, I don't believe they're commercially available.
Yeah, because they were just making those to do their stuff. So I don't even know you'd have to like even optimize some of the other language model code to run on them. It'd be a huge undertaking, I think.
Yep.
I imagine getting Microsoft's like their model to run on Google's TPUs would be like would be terrible.
So lastly, and this is just kind of a weird observation of having worked at an energy company, I have a pretty good guess as to what's going on with Amazon. I don't think this is Amazon hates the environment. They were the first serious cloud player in, and they did that leveraging a lot of their own infrastructure. So I suspect that those data centers were built where they never thought they'd scale to that size, where Google and Amazon getting into that business would have built data centers looking for renewable sources and things like that. I mean, much like the Apple Super Ring Center and those type of things. They were built in a different time period with different ideas of power consumption in mind. So I'm imagining they're just having a hard time as the first entrant there. And you can't just put a data center in Seattle and power panels in the desert in Nevada and connect them. I mean, you lose power transmission over distance is a big issue.
All right, defending them. I got it.
I'm just saying it may be more complicated than.
Still, if you want to stay relevant, you got to make the changes.
You would certainly hope that they're building new data centers over time with this in mind as they expand.
Hey, Amber, it's Ryan. I got a question. Can you hear me okay?
I can.
How are you, by the way?
I'm good. How are you?
Doing okay. This is really cool and a timely topic. I was having a talk with one of our data scientists this week about our language models, and we're having trouble. We're starting to get into places where we can't fit them all in certain types of servers in our Amazon environment. We're running out of VRAM and other things like that. But putting that aside,
you're one of those Amazon guys, huh? The
yeah,
17% renewable, huh?
Yes, we are.
Calling yourself out.
No, I mean, we'll be honest about it. We're actually, I didn't think about it. So I immediately started thinking about it from a cost standpoint of, going to more expensive and larger systems. And I'm just wondering if you've seen any numbers or have any thoughts on the other side of this besides the environment is the total overall investment. I read the GPT-3 paper that came out about a month ago, and I think the budget that was included in that paper was about $12 million to train that horrendously large model. And it makes me think a little bit. I'm not sure if you've thought about this, what your take would be, but what else could we as a technical community do with $12 million besides train a 11 billion parameter language model, right?
Oh, for sure, right? I mean, so for me, the question comes down to like, are we making sure that we're using the $12 million model for something that's like important, right? Like, like, are we using it for good, or are we just using it to make more money, right? Like that's for me what's really important. Like, if we're training up this model so that we're saving lives and we're doing really good things, then by all means, let's go forge ahead and spend the money and use the resources so that we're saving, the planet, so that we're saving the people, so we're solving cancer, whatever it is, right? But if we're training the model so that by golly, we can write some more papers and we can sell it and we can market it and whatever, then, you know what I'm saying? That's where I come down to. And I don't know if that's worth it, right? And
yeah,
if you can make an argument to me that making GPT-3 was a critical step towards the next phase of NLP research, you know what I'm saying? Okay, but did we just make marginal improvements on GPT-2? Did we just train it with more data, right? Like, then I'm not as
unfortunately,
okay.
you're right. Yeah, from the paper, if you've not read it yet, I'll spoil it for you, unfortunately. But you're absolutely spot on. It's more like GPT 2.5. It's a crap ton more data, a lot of extra money. There's some architecture changes, and on some metrics, some validation sets like Blue and some other ones, it does better than 2, and on some it does worse. It depends on the parameters
Yep.
and what's going on. But it's kind of negligible improvement, except for certain use cases.
Yeah.
And it was a hell of an investment to kind
They're
of
doing
just,
it because they can.
Yeah.
And it's
You
fine.
make a good point about the papers too. Did they train that so they could go write the paper and say, I trained an 11 billion parameter model?
Right. Well, and it's fine if they want to go spend the money. Like, it's their money. I don't care what they do with it. Right. But when it was just the money, I didn't care. But when I started thinking about, like, okay, did they just run, 25 cars how many times into the ground to research that model, right? Like,
Yeah.
Then it starts becoming all of ours problem.
It's a good point. Not to mention that some of these models are getting so large that, you and I at an enthusiast level, I'm an enthusiast, you're a researcher and a PhD, but I can't afford the hardware.
Call me an enthusiast, Ryan.
I corrected myself. You are a highly decorated NLP professor, PhD, doctor. No, some of these models won't even fit in standard machines. Like you're not going to bring a copy down to your MacBook Pro and use it.
Yeah,
you're probably going to have trouble fitting it in certain Amazon instances. You're going to have to get multi GPUs and split the model across. You have to parallelize their. It's insane the amount of effort you have to go through. Like, it's kind of out of reach for some of us, and unless you have the budget to spin up 4 servers with 4 GPUs each and architect that solution to run inference with it and to actually predict with it and use it.
No, they're doing it to say. I mean, they're doing it in some ways for the same reason that somebody builds Summit to make it slightly better than Titan, and I'm not even sure if I'm getting those in the right order anymore.
I got you.
You know what I'm saying? Like, I put one more server rack in there, and now I can say that I've got the biggest, supercomputer. Okay. How about we all go together, make a big one, and when we determine that it's not doing good enough, we go together and make a significantly better one to do what we need to, instead of just like throwing this stuff away. But I'm on a soapbox. I apologize.
To defend supercomputers, as you should know from working at Argonne, one of their primary missions is nuclear stockpile simulation. So the alternative to the supercomputer is blowing up bombs to make sure they still work. We stopped doing that in the 90s, right? So they do serve a pretty nice purpose in that regard.
No. And I'm not arguing against supercomputers. I'm arguing against, like, we have one and then China makes a slightly bigger one to say that we have a bigger one. And then we say, oh, well, ours isn't good enough again, so we're going to retire ours and make a bigger one. That type of race, that's what I have issue with. I wish we had bigger gaps between them, right? That's what anyway.
I have a question, a technical question. When you said features in these natural language models, do you mean like a vector in a vector space?
Mm-hmm.
Like the usual interpretation of feature in a machine learning model?
Yep.
Does anyone know, or do you know so like you have 17 billion of these vectors, features. Do you know the dimension of each vector by any chance, or have a guess as to what is it substantially larger than 17 billion? Is it smaller than 17 billion? Is it, any idea about that in these models?
I'd have to go look into that. I haven't even dealt with that particular one. And with BERT, like, that's the one that I'm most familiar with. You can kind of like, they have trained it up, and then they'll kind of give you the model, and then you can go do what you want with it. So some of the ins and outs, I'm much more familiar with the architecture and how they trained it than specifically those features. So like if you, now I got to figure out my presentation order. So in something like this, they take things like, so they work at sentence levels, they work at word levels, and they work at character levels, and they kind of go both ways and encode all of that stuff. And so once you get all of that plus the amount of data that they put into it, that's what essentially blows it out into that amount of features.
Yeah, I get the large number of features, but like, so if you just took the word, and I don't see word embedding on there, there's only sentence and token, but if you look at like a classic word embedding algorithm, like word to vec, the dimension of the feature space is usually much smaller than the total number of words in the language. You know, they're typically, in word to vec anyway, and in similar embeddings like that. And presumably that would be true for each of these types of embeddings. Now, however, of course, if you just look at characters, the fact, you know, there's a huge number of combinations of characters, so it's a much larger lexicon than just the number of words. But I just was wondering if anybody had a sense of the dimension of those vectors, if they were less than the number of features, or more than the number of features. And depending on that, there could be strategies, for example, I mean, one of the hot topics in efficiency of neural networks right now is compression, which is essentially projection, like these embeddings, right? To see if you can get the neural network to work in a tinier space and produce a similar quality output. And that how you would approach that problem would depend on the size of the problem. But I don't know I don't know much about NLP, so I don't know what's going on there.
Yeah, so in terms of like, let's see. I don't know if this is going to mess with my sharing or not. I think so. I think, let's see. I remember reading something. I think that Bert was using an autoencoder. So let's see.
That sounds right. I mean, all of these embedding, whenever you see a word like embedding, it's something.
Yeah. So
like an autoencoder.
The thing that I like the best for BERT, so if you just put in BERT language model, it's actually one of the first ones, and it's one of the ones that I think explains it the best. So I would start there. BERT explains state of the art. And so if you work through that, I think it actually gives a good bit of the depth, which I was kind of surprised about. And that's actually where I got the pictures from. But so I would start there and see if that gives you kind of what you're looking for. But I don't see that it gives the dimensionality. But batch sizes. Nope, I don't have a good answer for you. I apologize.
So I will riskily derail us a little bit, maybe open a can of worms. But I think this is actually a really interesting example of it has policy implications that folks should think about, and that you know, one of my initial reactions listening to your talk was that so here you are doing this at PwC and advocating for this. And the quants at Goldman are probably not thinking about this at all, right? And just burning away neural networks and other things on financial models over and over, right? And micro-optimizing things. And, you know, even if you don't view that as a one group versus another or a competitive situation, you certainly have to be aware of it and engage this, right? And it's interesting, you generally have, some look at something like a carbon tax that's been painted as a very democratic or left-leaning policy, right, as an environmental policy. But in fact, when you think about this kind of problem and how much research and work you have to do in order to understand what your cost and your impact is, there's a real argument that something like a carbon tax makes this, it's putting the free market forces at work to make this, everyone doesn't have to do this work. Your power actually starts to begin to bear the true cost of the impact. And then you level the playing field, and suddenly the person at Goldman is just as impacted as the person who is thinking about it actively within, like yourself.
It's deep, Tim. No, I think a lot about it. It's hard to sometimes feel like the ant in the anthill, and like what sort of impact like you have. Like right now, I gave this, it probably reached, I don't know, 50 to 100 people on webinar. So it's hard to tell how many people it actually reached, right? But I tried to phrase it as, hey, we should start getting a committee together, start talking about it. We actually have a strong push towards responsible AI and that sort of thing. And I tried to kind of frame it around that. I got no traction, but I didn't follow up either. So, that's neither here nor there, but I wonder how much it, requires, somebody pushing on it versus it requires the magic time and all the stars aligning, like sometimes you just need the catalyst and the time frame. And sometimes, you do need like an advocate, and I don't know which it is, right?
Yeah. I think you definitely have to look at personal advocacy and big solutions. I think it takes both to get those type of things done, right? But I would even think to technical ones as well. And this had me thinking, and again, I've no idea the feasibility of this, and we're probably not there yet with the libraries being ubiquitous enough. But it makes me think of something like SETI at home or folding at home or those other things, right? That you can volunteer time with if your computer's running anyways, use spare cycles in the background, and it, for various compute intensive causes. With a lot of gamers and gaming rigs sitting around with machines that are very capable of this, it would be interesting to see, like, if you actually, install the software as if your GPU is idle. There is cost still to using that, but it is idle to running is a lower cost raise from them not running at all, right? And so, you could even credit that person back for usage contributed or something like that. But if there aren't solutions like that would begin to contribute.
Right. Yeah. No, it's something I have I don't know. It's something I'm definitely passionate about. I have to figure out for me, like, what that looks like. And I don't know what that is yet. It's easier when you're passionate about a cause that's already established. I don't want to establish my own ground roots cause. Grassroots, ground roots. Roots are in the ground somewhere.
I'll jump in. Thanks, Amber. That was a great talk. I definitely didn't realize it was cars, lifetime cars, to train an NLP model. Could you give some context for that graph, the sort of exponential growth? It seems like it was flat for most of it, and then basically two big jumps. that really changed it, the y-axis. What changed? Like, what did NVIDIA and Microsoft have access to that like huge companies like Facebook didn't, that they were able to make such a bigger training set? And then related to some of like Ryan's questions in your paper you're discussing, like, did they see that much better results on any sort of performance metrics? Or how does this, if you had to draw this graph as improvement on test metrics, would it be as sharp of an increase?
Yeah, so I admittedly know nothing about the NVIDIA model. And that probably tells you all you need to know about its accuracy metrics. I don't think I heard anything about it, and I know nothing about it. But honestly, as far as I know, like none of these have done significantly better. Like they've all been sort of like incremental improvements, and it seems to be like kind of like the GPU race. Like we put more chips on our GPU, like we're doing better than everybody else. It seems to be that sort of thing. And honestly, what they did is they dumped more data, and my guess would be more redundant data, which would account for why they didn't significantly do better, and why things like Google and OpenAI didn't dump that much data in there, right? But I don't know that. That would be my supposition. I haven't dived into them just because I haven't needed them, and they're all just, I don't know, I may be boycotting them a bit. They do just feel like marketing gimmicks to some degree, because the Elmo was kind of one of the first, and it sort of came out, and then BERT has been like the one that got the most traction, and probably because it's Google and they put it out in the most like user-friendly, here, everybody can use it type thing, right? But I don't know, it's sort of been this like, everybody's doing it now, and I don't feel like anybody's doing it significantly better. And even you heard from Ryan, I mean, he read the most recent paper, and they're like, oh, we've got GPT-3, and it's like, we did better on some and we did not as good on others. And that's what papers are mostly about, which I understand is what research is, right? Like, totally get that. But most research isn't backed by $12 million and a ton of marketing, right? Like, that's what bugs me about it, is like, they're using it as branding and like throwing it out there to the industry as like, hey, I'm the best now. And to me, that's not what our research community is about.
Totally agree. And on the subject of branding, I looked up for eco AI for your new movement here, but it is already taken by a company in Vancouver helping people recycle using AI. So eco AI is taken.
All right, I'll find something else. Got to figure out something. Eco AI or the planet is doomed. Does that have a ring? No.
You keep going too long. Environment.
Okay, all right.
Yeah. You got to short. Think Twitter hashtag.
Dang it.
Twitter
I'm too old for the hashtags.
Oh.
This whole talk, Amber, kind of reminds me of the discussion. I thought some of these larger tech companies, I think Tim mentioned about data centers. I thought some of them kind of like how I'm forgetting some of this, so someone help me out. But I thought like some of the coal companies out there have to buy like environmental credits for the pollution they put into the air, and then maybe OpenAI next time they want to train their bazillion parameter model needs to buy some offsetting credits for the damage they're doing to the environment. Maybe that's part of the way forward.
I mean, it's a legit thing, but that's never going to happen until like there's more awareness. Like, that's where it's got to come from first. Like, people have to know that this is a thing, right? And honestly, until we get a little bit further, I mean, obviously they're doing tons of simulations. and I don't want to go after the simulation area because they're actually doing good things. My beef is that I don't know that these language models are actually doing a ton of good. I think we're just like doing them. So that's where I have issues with that. And maybe, you know, maybe they have to justify their use of it, right? Like you got to say, hey, this is where I'm like, you know, gonna actually do some good with it, as opposed to I'm just gonna market it and say my company's awesome. I don't know. I don't say that I have any, you know, public policy experience. Well, thanks you guys for having me. It's been a good conversation.
Yeah, thanks so much, Amber. Are there any lingering questions, anybody?
Just share your website once you have it up, and we'll all post it on our blogs and Twitter streams and whatever else will help you get the word out there, Amber. It's on you. Own it. Hashtag own it.
Totally. Put it on my blog in a few years because that's how often I blog.
Nice.
Well,
Yeah,
maybe
if you
Tim
want-
will put out the recording or something. That's about the closest I'll get.
Yeah, he'll post a video, and if you want to share anything with the group, like your slides or links to things for people to do, you could go to the meetup.com page. There's a place to comment, or send it to like me or Tim, and we can put it there if you don't want to sign up for Meetup or join our group.
Okay.
But yeah, happy to share.
Okay.
Thanks for
Thanks
the
for having
talk.
me.
It's a really, really good, really important topic. Thank you.
Thanks. Thanks so much.
Thanks, Amber. See you later.
All right.
Bye-bye.
Bye.
Thanks so much, Amber. Bye, everybody.